Okay, so we were looking at double integrals over general regions, and we talked about horizontally and vertically simple problems. And so now I want to do an example to show you where it really is going to make a difference. So here is an example. All right, so I have find the double integral over the region dA, where R is the region bounded by the curves y equals x squared and y is equal to 4x minus x squared. Okay. So if I have y is equal to x squared, so here's y is equal to x squared. And then I have y is equal to 4x times 4 minus x squared. And I know that's hitting at 0 and 4. So when x is 0, I'm confused. When x, okay, so the first one, all right, is, so this other one is like this. Okay, so this is the region R on the XY plane. So this is the region R that we're integrating over. And as you can see, if you fix an X, then this is vertically simple. As you can see, the Y value is vertically simple. So that y always starts on the bottom curve, which is y is equal to x squared, and always goes to the top curve, which is y is equal to 4x minus x squared. Now the question is, where does the, and so it's easy to see it starts at 0. The question is, what is this value of x? So how do you find that value of x, Anaya?
Don't you have to integrate?
I'm going to integrate to that value of x. The question is, how do I find out what that value of x is?
You integrate y first.
Okay, I don't think you understand my question. So let me rephrase it, because I'm not rephrasing it right, because I know you know the answer. Where do these two curves intersect? Right here. What is this value of x?
Oh.
How do you find when two curves intersect? What do?
Find it, what the area under the curve?
Not quite. If y equals x squared is on this curve and y is equals x squared is on that curve, if I set them equal.
Oh, I was about to say that. Set them equal to each other and then solve for x.
Okay, good. All right, so we get x squared is equal to 4x minus x squared. So therefore, I get 0 is equal to 4x minus 2x squared. So I get 0 is equal to, I'm going to factor out 2x and get 1 minus
No, it's 2x minus, I mean, it's a 2 minus x squared.
That's why I'm confused. Thank you. 2 minus x squared. Nope, it's just 2 minus x. Okay.
Yeah,
And
2 minus x.
yeah, so x is equal to 0 and 2. So now you know what this value is. So therefore, now I'm going to get the double integral over r dA. I clearly see I'm integrating with respect to y first because it's vertically simple. So that's going to be the integral from 0 to 2. The integral y goes from x squared to 4x minus x squared. And then in here becomes dy, and in here becomes dx. Okay. So that is the integral from 0 to 2. And then when I integrate this, I integrate dy, which just gives me y. So this is going to give me y evaluated between x squared and 4x minus x squared. And then this is dx. So now I get the integral from 0 to 2. When I put in y first, I'm going to get 4x minus x squared. And then I'm going to put at the bottom limit, I'm going to get minus x squared dx. So now I get, this is the integral from 0 to 2 of 4x minus 2x squared dx. So now I'm going to get 2x squared minus 2/3 x cubed evaluate between 0 and 2. And this turns out to be 8/3. And so that's it. Okay.
Mm-hmm.
All right. Next integral. So here's a problem. All right. Here, R is, so R is the region. Bounded by y equals x equals 1, and the x-axis. Okay, so the integral is the double integral over r of the cosine of 1/2 pi x squared dx dy. Okay, so now this is a tricky one. And the reason why this is a tricky one is because here we have, come on now, my region. All right, bounded by the line y equals x. And x equals 1. Okay, so here's the region. And it says integrate with respect to x first. Okay. So now as I look at that, I said, well, there's a problem. I can't integrate that with respect to x first, can I?
No.
Why?
Yes, you can.
No, you can't. You were right the first time.
Oh, it's because it's what's to call it? It's in there, like it's in the parentheses.
Mm-hmm. I need an x on the outside.
Mm-hmm.
If u is equal to 1/2 pi x squared, I don't have a u in there. So this problem as it is, I can't do it. So we're going to have to change it. Okay, so we change it to the integral, double integral over the region of the cosine of 1/2 pi x squared dy dx, and then hope that we get what we need. Okay, because we definitely can't integrate it with respect to x first. So now we have to see where y goes. So if I fix a y, I can now see this thing is horizontally simple. And it goes from x equals y to x equals 1. Okay.
Wait, so what you do different?
So,
You
oh,
did
I'm
the y
sorry.
first?
That's the way it was originally.
So you
That's
put
the
dy
way it was.
dx instead?
Yeah, that's the way it was originally. I apologize. I was doing, yeah, let me go back and do it the way, now I got to do it the other way. I got to figure out where y goes from. So I have to fix an x. Fix an x. And now I see, now it's vertically simple. So y starts at 0. And then it goes to y equals x. And then x is going to go from 0 to 1. Okay.
Yeah.
All right. So now I have the integral from 0 to 1 of the integral from 0 to x of cosine of 1/2 pi x squared dy and then dx. So now this is the integral from 0 to 1. At least now I can integrate it with respect to y. Because when I integrate it with respect to y, I get y times the cosine of 1/2 pi x squared. Evaluate it from 0 to x dy. I couldn't even begin, I'm sorry, dx. I couldn't even begin to integrate it the other way. So now I have the integral from 0 to 1. When I put in x, I get x times the cosine of 1/2 pi x squared. And then I put in minus 0, so that knocks it out. So I just get that dx. Now that's integrable. Okay, so if u is 1/2 pi x squared, du is pi x dx, and then x dx is 1 over pi du. And if x is equal to 0, u is equal to 0. And if x is equal to 1, u is equal to 1/2 pi. So this becomes the integral from 0 to 1/2 pi of 1 over pi cosine of u du. And that becomes, that's not the answer I got. That becomes the sine 1 over pi, the sine of u, evaluate between 0 and 1, and 0 and pi over 2. So that's 1 over pi. The sine of pi over 2 is 1 minus 0. So I get 1 over pi. And that is the answer. Okay, any questions?
No, so you have to integrate it dy first,
Yep.
and then you do it dx.
So I'm gonna give you another one and show you this one. Now, this one's a little bit more difficult. This one, I don't tell you the region. This is the double integral. Oh. This is the integral from pi over 2 to pi. The integral from 0 to y squared of the sine of x over y dx dy. Now, I think this one, let me see. This one, you have to integrate with respect to x first. So this one is okay. Yeah, this one you have to integrate with respect to x first. Okay. So when I integrate with, so I'm going to take, and I'm going to get the integral of pi over 2 to pi. And when I integrate this in the middle, what do I get when I integrate that?
So with respect to x first,
Yes.
cosine x over y, and then that's over y.
Is it over y or times y?
Times y.
It's times y. And is it positive or is it negative?
Positive. No, negative.
It's actually negative because when you take the derivative of cosine, yeah.
Positive.
Okay, so this is evaluated between pi over 2 and pi. Okay. And then I still have dy left. I am thoroughly confused.
Me too, not gonna lie. And then you plug in the pi for the x, right?
Yeah. And that's why I'm confused. Why? Where did I get this problem from? Okay, let me tell you why you know, you know what, actually, because when you integrate this thing with respect to, you can't integrate it with respect to y. You have to integrate it with respect to x first. But when you integrate it with respect to x first, oh, I know what the problem is. Duh. Okay, I'm dense. I put the wrong limits. The limits are supposed to be y squared and 0. That's why. Now, okay. That's why I was confused. Okay, why were you confused?
Oh, I didn't know that you wrote it wrong.
Okay, does it make sense now or are you still confused?
Yeah, because you used the thing at the top.
Right. Before, the way it wasn't going to be integrable. Now I can integrate it. I couldn't integrate it a minute ago.
Because
now,
you had to use the y squared.
Right. So now
I
have pi over 2 to pi. I can take the negative out and I have y. And then in the first piece, I'm putting y squared in for x. So I get the cosine of y. And in the second piece, I put the 0 in for x. So I just get 1. Okay, now that's what I get. So I get, I can leave it just like that. And I am going to do this by parts. So I have y, then I have 1, then I have 0. I have the cosine of y minus 1. I have the sine of y minus y squared. What in the world am I doing? We doing this crazy. We get
Wait, what is,
and then I have minus cosine y. Okay, because this turns out to be the integral from pi over 2 to pi. And then I'm going to get, when I multiply by -1, that gives me 1 minus cosine y. So I'm going to get y minus y cosine y dy. Do you see that?
oh, yes, you just distribute, right?
Yes.
Okay.
All right, so now the first part just becomes 1/2 y squared.
Mm-hmm.
And then the second part comes from the integration by parts. So the integration by parts, this is positive and this is negative. So I'm going to get minus y sine y. Minus the negative is going to give me plus cosine y. Evaluated between pi over 2 and pi. Okay. So we get 1/2 pi squared. We're going to get 0 here, and then plus cosine of pi is -1. Then we're going to subtract off 1/2 pi squared over 4. And then I'm going to get minus, the sine of pi over 2 is 1. So I'm just going to get minus pi over 2. Cosine pi over 2 is 0. Okay. Do you see that answer now?
Mm-hmm.
Okay. So we integrated, we got minus cosine, we got the y popped out, we got minus cosine of x over y dy. Then we put in the values. When you put in y squared, you just get cosine of y. When you put in 0, you just get cosine of 0 is 1. Then we flip it because we get, it would be minus y cosine y minus a negative y. So that's perfect. The first piece we integrate gives us 1/2 y squared. We integrate y cosine y. We integrate cosine, we get sine, integrate sine, we get minus cosine. Then we have y1, 0, so y sine. Okay, so then we subtract off the integral of y cosine y. That gives us minus y sine y plus cosine y. Evaluate it between pi over 2 and pi. We get 1/2 pi squared, so that's pi squared over 2. Minus 1. This is going to give me minus pi squared over 8. And then I'm going to get minus plus pi over 2. So that gives me 3 pi squared over 8 plus pi over 2 minus 1. Okay.
Who's that my turn?
All righty. Okay. So now let's evaluate new problem. So I have the double integral over R of 6x plus 2y squared dA. And R is the region. Bounded by x is equal to y squared and x plus y is equal to 2. Okay, so now I want you to go ahead and graph that, Anaya, and tell me whether it is horizontally or vertically simple. Are you there?
Yeah.
Okay.
And how can you tell again if it's vertical or horizontal?
Okay, so it's vertically simple if it always goes from one curve to another. And it's horizontally simple if it always goes from one curve to another.
I say it's vertical.
Okay, did you draw it?
Yeah.
Can I see it?
It's electronic. I didn't draw
Oh,
it out by hand.
oh, okay. All right, well, I'm gonna draw it. You tell me what you think. Okay, x is equal to y squared looks like this.
It's like a parabola. Yeah, that's too.
Okay, and then x plus y is equal to 2 is 0 when x is 0, y is 2. And when x is 2, y is 0. So I get this line right here.
Mm-hmm.
Okay, so here's the region. So the region is all of, I don't want to use that dark color. The region is all of this inside. And I asked you, is it vertically or horizontally simple? And you said you think it's vertically simple.
It's a horizontal.
It is horizontally simple. It's not vertically. If I'm at this point here, I go to this curve. And if I'm over here, I go to that curve. So that,
Oh, wow. So if it's vertical, how would it look if you draw the lines? It would look horizontal.
so right now, see how I drew vertical lines?
Mm-hmm.
And when I draw vertical lines, they don't always go from the same curve to the same curve.
Mm-hmm.
Okay, so let's try to draw horizontal lines. If I draw a horizontal line, on the other hand, no matter where I draw my horizontal line, it always starts at one curve and goes to the other.
Oh, okay.
So
I
it's
get it now.
horizontally simple.
Okay, okay, that makes more sense.
So when it's horizontally simple, I have to integrate with respect to x first. Okay.
Mhm.
So now what I need to know is where are my y values? If I'm integrating with respect to x first, this line has to start. That line starts down here and goes up here. So I have to find the y values. So
So you
again,
have to set them equal to each other.
yep. So tell me what my y values are.
Wait, I have to set them equal to each other, right?
Mm-hmm.
So I'm solving for y.
Yep, or x. You can solve for x and then get y, or solve for y first, but either way, I need the y value.
All right, hold up. Uh, 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 uh. Uh, his 1 and -2.
That's right. Okay, so you get so therefore you get the integral, y goes from -2 up to 1. X starts on the curve x squared, y squared, and it ends on the curve what?
You said x squared equals y squared, so x plus y equals 2.
Can x be in the exponent, in the x is a integration variable? Can it be?
Oh no, it's y. It's y squared and then 2 what is it? 2 minus y?
That's perfect. Okay, and then you have 6x y squared that's inside dx dy. Okay, can you integrate that? I know you can. I want you to do it. -2 to 1, and what goes on the inside?
3x squared plus 2xy squared.
Okay,
And then you plug them in.
all right, so what do you get? First piece, 3
2 minus y squared plus 2, well, 2 minus y, and then y squared, and then subtract 3x, well, 3y to the fourth plus 2y to the fourth.
Okay. And this is a subtracted because why?
Oh, because I thought you were gonna keep a parenthesis because you distribute the minus sign.
Right. Oh, okay. I got you. I'm
It
glad.
don't matter. Same thing.
It's gonna come out in the wash, girl. Very good. Okay, so now we get the integral of -2 to 1. Inside, I'm going to get 3 times 4 minus 4y plus y squared plus 4y squared minus 2y cubed minus 5y to the fourth.
So it'll be 12 minus 12y plus 2y squared. And then plus 4y squared minus 2y cubed minus 5y to the fourth. And then you just combine like terms, so it'll be negative 5y to the fourth minus 2y cubed plus 7y squared minus 12y plus 12.
And to spare us all the algebra, comes out to be 99/2. Very nice number.
45. No, that's 55, right? No, 49.5.
Yeah. Okay. All right, so that is the end of this section. I will start the next section next time. And then Wednesday have questions for the exam. So I will
Okay.
add homework and stuff like that, you know, on those sections. I reset the quiz and you can come with some problems.
Okay, thank you.
All right, thank
How
you.
long is the quiz now?
35 minutes.
Okay, that's so much better because I was like pushing it.